The last video that we're going to be going over is molecular formulas, and you really need to know how to do an empirical formula so that you can be able to get a molecular formula. Like we mentioned earlier, sometimes the molecular formula will be the same as what you experimentally are able to determine the empirical formula to be, or it's going to be a whole number multiple of that empirical formula. But you do need to know the molar mass of your compound. If you do not know the molar mass of your compound, then you can't figure out the molecular formula. So that is a requirement. Alright, once you have the empirical formula, you have to know the molar mass of your compound. Alright, let's go through the three quick steps, and then we're going to do a few practice problems together, and you're going to be doing one on your own to see how you're doing with this. So step number one is we need to use the empirical formula and calculate what the mass of the empirical formula is. We're going to abbreviate that as EFM. So it's like the molar mass, but it's for the empirical formula. So we need to do that first. And then once we know what that is, we can take our molar mass, which again has to be given to us, and we need to divide those. We can take the molar mass, divide it by the empirical formula mass that we calculated in step one, and that will give us a multiplier. So maybe if it's like 50 divided by 25, well, then that means that your molar mass was 2 times greater than your empirical formula. So once you know what that multiplier is, you're going to multiply every element by that amount, and that's going to be your final molecular formula. So let's go through an example here. We already took a look at HO being the the empirical formula for hydrogen peroxide, but let's show how this would work. So we know that the molar mass is 34.0 grams per mole, okay? And that is for the molecular formula, okay? The molecular formula is 34.0 grams per mole. I think I probably typed that up a little funny here. We want to find the empirical formula, which we know is HO. We need to find the mass of that. So in step number one, we're looking for the empirical formula mass, all right? So we have to take HO is that formula. So we're saying that we have 1H, that's 1 times 1.0, because that's the mass of hydrogen. Oxygen, we have one of those, and it's 16.0. So if we take a look at that, you have 1.0 plus 16.0, 17.0 grams per mole. That's what the molar mass of our empirical HO is. But our actual compound that we have has 34.0 grams per mole as its mass. So for step number two, we take the 34.0 grams per mole, and we're going to divide that by our empirical formula mass of 17.0, and when we do that we get a multiplier of 2. So that means that our molar mass given to us was 2 times greater than that 17.0. So our step 3 says that we use that as a multiplier. So our empirical formula is HO, and we're going to multiply that by 2. And that is going to, kind of in math, when we distribute that, you have to distribute it to everything within the formula. So we end up with H2O2, hydrogen peroxide. Alright, let's try a new one. We have to calculate the molecular formula. We know that the molar mass of our compound is 60.0 grams per mole, and we know the empirical formula, CH4N, and we want to find out what our molecular formula is again. So step number one, we need to know what our empirical formula mass is. So the mass of CH4N, we have 1 carbon, and that is 12.0 for every 1 carbon. Hydrogen, we have 4 of them. Each one has a mass of 1.0. And then we have nitrogen, and if we look at that one on our periodic table, 14.0. Alright, so our total empirical formula mass is 30 grams per mole. And step 2 says that we take our molecular formula of 60.0 and divide that by the empirical formula mass of 30, the one we just calculated in step 1. And again, that gives us another multiplier of 2. So our third step is to take our empirical formula of CH4N and multiply that by 2. So our molecular formula is C2H8, because we're multiplying it by 2, and then N2. Alright, so that's how we do a molecular formula. And this third one I'm going to have you work out on your own. Again, you're going to need to find the formula mass of CH3O. That's step number 1. We're going to take our 62 grams and divide it by whatever you calculate in step 1. Whatever that multiplier is then, you're going to multiply each one of these by that multiplier to get your final molecular formula. Again, if you have any questions, please email me or text me. Come see me before or after school, whatever's going to work for you, but definitely come in and get help if you're not sure how to do this. Have a great day.